The staff scooped up a spoonful of ashes and placed it on a ceramic plate. Then she put the ashes into the elemental analyzer in order to analyze the percentage of carbon in the ashes. When the ashes were put into the high-temperature furnace, the ashes will burn in oxygen. The oxygen and carbon react to produce carbon dioxide. By measuring the amount of carbon dioxide emitted, you can predict the amount of carbon. When a human body is cremated, it leaves between 1 and 8 kilograms of ashes. This contains only 1% to 5% carbon. But if the carbon content is less than 1%, diamonds cannot be made. Once the carbon content is determined, the lab technician separates the carbon from the residue. She adds a special mixture of acids to the beaker. This dissolves all the non-carbon elements in the ashes. After 2 hours, the experimenter pours the liquid into a suction filter to filter out the carbon. Then the moist, only 1 to 2 grams of crystalline carbon was left to dry. When it was dry, the experimenter pressed the carbon into a disc shape in order to synthesize diamonds. They had to replicate and accelerate conditions that existed only deep below the surface, 161 kilometers underground. Under extreme heat and pressure, it still takes billions of years to turn crystalline carbon into natural diamonds. Then the diamonds would come to the surface with volcanic activity. But the lab doesn't have a million years to wait, so the graphite discs will be placed in a small capsule called a growth chamber. The growth chamber is composed of all the conditions needed to form a diamond. It includes a small piece of natural diamond flake, also known as a diamond seed. Under high temperature and pressure, the mixture of all the components becomes a solution of dissolved carbon. The carbon atoms will migrate to the seeds and recrystallize, and the process still takes a month. The experimenter places the freshly assembled growth chamber into a high temperature, high pressure container. This 15-ton container, developed by Russian scientists, is so heavy that it needs to be reinforced. The floor of the laboratory to support its weight. The experimenter puts the growth chamber into the central housing. Then it was secured with an electric ring, the material for the top and bottom of the vessel, made of a hard alloy that exerts pressure. This high-temperature, high-pressure vessel heats the growth chamber to 1,482 degrees and squeezes it at a pressure of about 1.55 million tons per square meter. If the temperature or pressure drops by 0.2%, the diamond will be destroyed or stop growing. Over the next few weeks, the growth chamber will be subjected to incredible heat and pressure. A month later, the experimenter took the growth chamber out of the container and smashed the chamber open with a hammer. This is when a raw diamond is revealed. The chemical composition and physical properties of a synthetic diamond are the same as those of a natural diamond. After the diamond is cut, the lab technician will engrave letters according to the customer's needs, and the letters are so small that you can only see them by magnification. Remains with a high concentration of boron produce blue stones, whereas remains with less shed will produce white or clear diamonds. Each morning diamond is a unique representation of its owner. For the rest of their lives, their loved ones will be with them in another form.